to last week or the week before when we started doing exponential modeling, we started with a problem that was talking about bacteria in a swimming pool. And we said that we had a really small amount of water and there were a ton of bacteria in it. And our goal was to figure out how long it took until there were 3 million bacteria in that teeny tiny little space. And we ended up writing this highlighted equation on the left. 3 million equals 1,500 times 2 to the t. So before we move on, let's review some exponential modeling here. What does that 1,500 mean in terms of the bacteria? That was the starting amount. So we started with 1,500 bacteria, and what does the 2 mean in terms of that? It doubled. So the number of bacteria doubled every hour, and our job was to figure out how long until we got to 3 million. And then we said, well, we don't really have the tools to solve that equation yet. But at least we can get started on it, because we're going to finish this problem up tomorrow. It's going to be like, it's like a 2-week long. It's the longest problem we've ever solved in terms of time.
2 weeks or something?
Yeah. Well, we set it up last week, and then today we're going to get halfway there, and then tomorrow we're going to finish solving it. I know, you've been thinking about it all night, every day, right? Yeah, you can't even sleep because you don't know how long it's going to take. All right, how can I get from this left equation to this right equation? What would you do, Rachel? Divide by 1,500. So at least you could do that. I mean, that part's not new. And you can take my word for it that 3 million divided by 1,500 is 2,000. So once you divide, you get 2,000 equals 2 to the t. Now here's where we keep getting stuck, though. Because we can divide by 1,500, but do you, in your mathematical brains, know how to get the t out of the exponent? No. That's where we're stuck. But that is where logarithms are going to help us. So we first need to understand a little bit more about logarithms, other than graphing them, so that tomorrow we can get that t out of the exponent. Okay, so here's what we have. We have a definition of a logarithm. We talked about this yesterday. Well, my highlighter's not working. There we go. We said that if you have an exponential function, y equals b to the x, then the logarithm, that was its inverse, right? We said graphs of logarithms were inverses of exponentials, has this equation. Log base b of y equals x. Now, we're going to talk about that definition a little bit, and we'll help you remember, like, once you see it with numbers, it will make sense. Because yesterday, when we had x's and y's and b's, it looks a little funky. But when I get to example 1 here, where I start to put numbers to it, you're going to see exactly what the logarithm is doing. So let's use this definition of a logarithm to rewrite 10 squared equals 100 in logarithmic form. Now what logarithmic form means is you have to have the little symbol log in there. So that's where you start. You're going to write log. Now let's look at the definition here. When I write a log, it says log base b. Now b was the base of this exponential. So when I write this problem, I'm going to have log base, what's the base here? 10. Log base 10. So 10 is a subscript. It's a little lower and it's a little smaller. Now let's think about the next part. I have log base b of y. Now in my exponential, y is what you're equal to. So here I have log base 10 of 100, what I'm equal to. So log base 10 of 100, it says equals x. Well, in my exponential, the x is the exponent. So what's the exponent down here? 2. So 10 squared equals 100. If I wrote that in logarithmic form, that is log base 10 of 100 equals 2. Now the connection we should be making here, notice that 10 is the base in both the exponential and the logarithm. So if I look at, oh well, apparently my highlighter's not working today. The base of this exponent is 10, or the pens, it's all good. And the base of the exponential, it'll show up in, there we go. The base of both of those is 10, so the base is always the same. The next thing we have to notice is that the logarithm, what it's equal to here is the exponent of the exponential. Okay, so we have the same base, and what the log is equal to is the exponent. Now I'm going to show you a little trick because once you get the pattern of this, because we'll do a couple more here, you'll see how this goes. But sometimes it's easier to think about this little pattern of a curly Q. So if I think about the 10, we have 10. If I were to draw a curly Q here, 10 to the second power is 100. Does that match this what we have here, right? And I can do the same kind of curly Q to help me write the logarithm. If I start at the base, 10, or log base 10, log base 10 of 100 equals 2. So if you start at the base and end at the exponent, that tells you the order that you need to write the numbers. So let's do a couple more. We'll see. You'll pick up on it real quick after we do these. So we need to write these in logarithmic form. So again, we start at the base. If you need to draw curly Q, start at the base, go around to the answer, and end at the exponent. So this will be log base what? What's the base? Log base 6 of 36 equals the exponent of 2. That's how you write that in logarithmic form. What about 2 to the 5th is 32? How could you write that one? Log base 2 of 32 equals 5. Now, one thing you should at least notice about all these is that the logarithm, it's always equal to the exponent. So the exponent of the exponential is equal to the logarithm. So that connection is going to help us later. Exponents and logarithms are the same thing. Now we can go backwards. And going backwards is where I think you'll really start to see this connection between a logarithm and an exponent. This is what you were doing on your slip just a couple minutes ago when it said like, what did it say? Logarithm base 10 of 100 or something like that. That's what it said on your paper. This is what it was actually doing. That's the math symbols for it. So let's see. We want to write this in exponential form. So the curly Q thing works here. Again, you start at the base. Start at that little number. Go around to the answer and end at the big number. So if I wrote that in exponential form, I would write that as 4 to the second power equals 16. Now, is that a true statement? Yes. So because it's a true statement, that means that if you messed up and you wrote 4 to the 16th equals 2 or something like that, that's definitely not equal, correct? So you should be able to use your math power and know how to write that correctly so that you make a correct math statement. Well, what about in B? How would you write this exponential expression right here? What would you write? 6 to the 0 equals 1. Is that a true statement? Yes. All right. How would you do the last one? 3 to the t equals n. Good. Good so far? Does that make a little more sense than just the definition we did yesterday? A little bit. Okay. Now, we're not quite to the really cool logarithm stuff, but we can at least solve some equations with logarithms. So now we're going to turn this into something with a variable. We need to find the value of x. So anytime you have an expression with log, written like this, then you need to find x, we first need to turn this into an exponential expression. So I would at least start with your little curly Q thought. You don't even have to write the curly Q, but think about it. And rewrite this as 9 to the x power equals 81. Now I know we don't technically know how to get x out of the exponent yet, but can you tell me what x should be? 2. That one's easy. So x equals 2. Same idea for b, only the problem's going to look a little bit different here. 8 to what power? 8 to the third equals x. Well, x is easy to find this time because you should know what 8 to the third is. What is it? You should. 512. Kind of close. That's on the know your powers. You should know that one. 512. All right, the last one here. It's not that complicated, but it looks a little more complicated. Start with an exponential, because this one you can't guess. The other two you probably could have guessed without writing an equation down. This one is going to be a little bit more work. Rewrite this as 5 to the second power equals 3x plus 1. Well, now you just have an equation. What's 5 squared? 25 equals 3x plus 1. And you're going to solve that for x. Right, you'll subtract, you'll divide. You write down as many steps as you need to. And what do you get for x? 8. Good. Not too bad yet? We're not fully solving equations with logs, but we're solving something. So if you turn your page over, there are 3 problems at the top I want you to try. We're going to come back together in like 2 minutes here, and where are the answers for those 3? Look at them. Do you want to see any of them? I'll go over any of those. Nope. You understand how to do these all? You're good? All right, if you can do these, you'll be fine for your quiz on Friday. So I'll have one little template quiz then. Okay. All right, let's learn about our calculator stuff real quick. There are actually 2 kinds of logarithms. And yes, you are going to have to know the difference, and you're going to use them in different places. We'll start to figure that out tomorrow. So logarithms, there are 2 kinds. One of them is saying it uses 10 as the base. Okay, so that would be like if you wrote log base 10, like log base 10 of something. I'll just use x. Right? Anything with a base 10 is really common. So we call it the common logarithm, because mathematicians are not creative. So that common logarithm means that your logarithm has a base of 10. Now, there's a shorthand, because it is so common, and they use it all the time, the shorthand is that they just write this as log of x. They don't put the subscript of 10 on it. So if you ever see a problem that says log of 100, what that really means is log base 10 of 100. Okay? Which, if you're thinking about what a logarithm is, it's asking you for an exponent. Right? So it's a 10 to what power gives you 100. And we'll spend more time with this as we go. But remember, a logarithm gives you an exponent. So if we use look at number 5 here. I have log of 78. I want you to take your calculators, so pull them, turn them on, and we're going to evaluate log of 78. So when you pull up your calculator, that is not the calculator, here's the calculator. Where's the log button?
Right next to the 7.
Right next to the 7. You just hit log. Now, if you have a TI Inspire, which I think you are the only one, do you know where the log, can you find the log button there?
No.
Okay, you're going to have to hit Control. It's in blue. Oh, yeah. Once you turn it on, and you'll hit Control and then the X. Yep. So get you.
Bro! That's psycho!
I just like made it quick.
He created math.
All right, so we have a log of 78. What decimal does it give you? 1.892. So let's go back to our notes. Log of 78 is 1.892. Now let's talk about what that means. Because again, I'm trying to make connections here about what a logarithm does for you. This logarithm, remember, it's a common log. So without saying it, it has a little invisible 10 there. Log base 10 of 78. You don't have to write the base 10, but you should know that that's there. Now think about what a logarithm does. We've just been writing these in exponential form. So if you think about that curly Q idea here, what that answer is it's saying 10 to the 1.892 power should equal 78. Right? That is what the logarithm is doing. When you push that into your calculator, you're finding the exponent for 10. So let's double check. Type into your calculator now 10 to the 1.892. Now, do you get exactly 78? No, but why do you not get exactly 78? Because we round it, but that's close enough, right? So you know, like, does that make sense to you what we're finding with the logarithm here? All right, now, if we go back to our paper, the second kind of logarithm, because, you know, we can't make things easy. The second kind of logarithm is Bobby's favorite number,
Yes.
which is E, your new
Yes.
favorite number. We also, it's very common to have logarithms of base E, and these are used in different scenarios, which we'll start to learn about tomorrow. If you have a log written, it's kind of small up here, but it says log base E of x. And that's what it says on your paper. I don't know how easy it is to read on your paper. That is called the natural logarithm. Okay? So it's called the natural logarithm, not the common. And there's a shorthand for the natural logarithm. So you don't have to write log base E. The shorthand here is ln x. Now, I only said ln x because I was telling you like what to write down, the letters, but please don't say ln of x. It's called the natural log. It's ln first, though, because French people came up with it. They say log natural, right? Because French people mix, like if you take French, they reverse the words a lot. But it's log natural, the natural log of x. So it's like when you did in geometry, sine, cosine, and tangent. Please, I'm sure you did this, but like if you said like cosine of 78 and you say like cos or cos 78, that's like nails on a chalkboard to me. It's like cosine, it's an abbreviation. Say the whole thing. So don't tell me you're trying to find ln of 126. You're trying to find natural log of 126. When you're a math teacher, you can say it however you want, but in my classroom, say it the right way. Math dictates. Or what? Or I'm going to correct you. That's pretty much it. Alright, so we have the natural log here. Let's take our calculators. Let's figure out where the natural log button is, just in case. ln. Someone in the last class said they thought it was in. So now you know it's ln, natural log. It is right below the log button, right next to 4. And then here's right next to it. So we do natural log of 126 and hit enter. 4.836. So when we go back here, we have that equals 4.836. Now again, let me remind you where this comes from. What is the base of the natural log? That's not written but implied. E. So this is really an invisible E right there. Okay, you don't have to write the E, but know that it's there. This really says what your calculator just found for you is the exponent that you raise E to equal 126. Okay, so when you type log or natural log of something in your calculator, you're trying to find an exponent. That's what it does. So let's check. E to the 4.836 power. So there you go. Second natural log is e to the x. And 4.836, you get about 126 here? All right. Or in our last one, it's a short one. I'm going to split you up because it'll be so short, it'll save us some time. Oh wait, no, I lied. Well, yeah, it's okay. Let's skip to example 7. You're good. Example 7, because I was on the roll, so we're not going to go back. These two rows, I want you to find in your calculator log of 10. You guys, I want you to do natural log of E. Okay, so try each of those. I want you to tell me what you get for each one here. If the people with the E have trouble, you either need to make the exponent 1 or there's a second E button that doesn't have an exponent. So basically, there's like an E on the bottom. Power. Yeah, what'd you guys get for log of 10? What'd you guys get for natural log of E? 1. Now, here's why, but I'm going to tell you, you should know these. These ones, like, and I don't want to say, like, memorize it, but the natural log of E especially is going to make your life a lot easier if you know that it equals 1 later on in this unit. But let's review y really quick, and then we're done. Remember, there's an invisible 10 here as the base of the log. So what this is saying is 10 to the first power equals 10. Do you agree with that? Yes. Same thing for natural log. E to the first power equals E. Okay? So here's what you need to do to finish up today. You need to pull out that homework packet from yesterday. We had the graph on there. There's some multiple choice in number 2. Try number 2 to finish the packet. I know it seems like a lot, but it goes pretty quick. You have the whole